Hello again, grade 8s. In today's lesson, we're going to continue to look at calculating the surface area of three-dimensional objects, although this time around we're going to focus exclusively on right triangular prisms. And our learning outcome being to determine the surface area of right triangular prisms to solve problems. But let's define what a right triangular prism is. So a right triangular prism consists of 5 faces with 2 faces that are congruent triangles, and we call these 2 congruent triangles the bases of the right triangular prism. So in the illustration I see here, I'm going to shade in what these 2 triangular bases would be. So this is the first triangular base, and this is the second triangular base. Those sides are parallel to each other, which means those sides are the same distance apart, and they're congruent triangles, which means they're also the exact same size. So that is a triangular base at the front, and you also have a triangular base at the very back. Your other 3 faces are rectangles. So I'm just going to erase what I've kind of shaded in here, and I can show you those other faces. So we have at the very bottom, we have one rectangular face. On the right-hand side of the triangular prism, we have another rectangular face. And then our third rectangular face is on the left-hand side. So I'll try to shade that one in. That's this one on the left-hand side. Okay, those 3 faces, those 3 rectangular faces and those 2 parallel bases, they make up a right triangular prism. And again, you have 3 rectangular faces. The other key thing is that for it to be a right triangular prism, and again, that word right is implying that it has something to do with a 90-degree angle. The reason it's a right triangular prism is that those triangular bases intersect the rectangular faces at a 90-degree angle along an edge. So I can just point out one of these just to kind of show you like what the 90-degree angle looks like. So let's take one of the bases. So this one right here. And let's take one of the rectangular faces. So I'll do this one. Oh, got a vertical line that I don't want. And I'm just going to look at the angle between this base and this rectangular face. So I'll do that in purple. So if I look at the angle between this edge and this edge right here, this angle, I can try to draw a small square in 3 dimensions, is a right angle. And all of your triangular bases intersect the rectangular faces at a 90-degree angle. All right, so we're going to jump into the example now. So we have 2 examples of some right triangular prisms, and I want to calculate the surface area of every single one of these. So again, the way to calculate the surface area is it's just the area of every single outside face, and then you add them all together. So in my solution, I want to do the same thing I did last time, which is we draw each distinct face and then label the dimensions, and then calculate the area of every single face individually. Then we're going to put it all together. I should point out, though, just before we get this started, just as a reminder here, the area of a rectangle is equal to the length of the rectangle times the width, or if we just don't show the multiplication operator, it's L times W. We're also going to use the area of a triangle. The area of a triangle is just the area of a rectangle cut in half. So that's going to be length times width divided by 2. Or I can write it down as length times width as a fraction, LW divided by 2. Okay, so we need to use both those pieces of information to solve these. Okay, so let's start off with this first triangular prism. Now, I have to draw every single distinct face. So let's start off with the triangular bases. So the triangular bases are going to be this one, this face, and the one at the very back. Okay, so the one at the very back would be, let's do it in blue. This one right here. Okay, so let's start off by sketching what that looks like. Okay, so let's go up here, and I'm going to say my triangular bases. Okay, let's underline that. All right, so let's sketch that triangle. And let's go ahead and label the dimensions. And I can show the right angle here as well. Okay, so we've got a length that is 8 centimeters. And you have a height that is 6 centimeters. And this base repeats twice because you have one at the front and you have one at the back. Now, I want to calculate the area of this. So the area of this one would be, this is the area of a triangle. So I'll write down A bases. And that's length times the width divided by 2. So we're going to go 8 centimeters. Multiply by 6 centimeters. Divide this by 2. So the area of the bases would be 8 times 6 is 48 square centimeters. And you cut that in half and you're going to get 24 square centimeters. Okay, so those are the two triangular bases. Now, let's erase this and let's look at the other faces now. So let's go now to the top rectangle. So I'm going to go to the one at the very top here. So this one. Okay, so I'll write down top rectangle. From a top view perspective, it would look something like this. Okay, the length of this rectangle from the top, that's 10 centimeters. That's going to be this bottom dimension. And then the width is going to be the 4 centimeters. So to calculate the area of the top, we can say area of the top is just the area of a rectangle. So that's just going to be base length times width. So it's going to be 10 centimeters multiplied by 4 centimeters. And then area of the top would be 10 times 4 is going to be 40. And the units are square centimeters. Okay, this face only repeats a single time though. There are no other faces on the right triangular prism that actually share those dimensions. Okay, so let's erase this now. Now let's go to the left side face. Okay, so that's going to be this one. So we'll say left rectangle, or left face would be fine too. Okay, so this one, if I draw it, so if we're viewing it from the left-hand side, so we're approaching it, looking at it from this perspective, the length of it would actually be this number, the 4 centimeters. Well, it's actually the width of the prism. And the height is 6 centimeters. And this only repeats a single time. So we can say area of the left rectangle would be equal to length times width, which is 4 centimeters. So we're dealing with a rectangle, times 6 centimeters. And then I have the area of this left face would be 4 times 6 is going to be 24. And the units are square centimeters. So far we have 1, 2, 3, 4 faces. So a right triangular prism has 5 faces to it. So the one remaining face we have is going to be the bottom one. Okay, this one at the very bottom. Okay, bottom rectangle is going to be similar to the top one, except it's not quite as long because it only has a length of 8 centimeters compared to 10 centimeters. So maybe something like this. So the bottom rectangle is 8 centimeters long, and it has a width that's 4 centimeters. Oh, I just realized I didn't show the dimensions properly on this one, so let's fix that. We should be showing those lines with those edges. So, yeah. Four centimeters. And then got the 6 centimeters here. Yeah, that's the best way to label the dimensions. Okay, and then we can write down A for the bottom. Is equal to area of a rectangle, which is length times width. So you have 8 centimeters multiplied by 4 centimeters. And the area of the bottom would be 8 times 4 is 32, and the units are square centimeters. And this only occurs one time. All right, so now the total surface area is going to be 2 times the area of a base, because you have 2 of these triangular bases. So I'll write down 2 A bases, plus the area of the top rectangle, and it only occurs one time. So let's write down plus A top, plus the area of the left rectangle, so A left, plus the area of the bottom rectangle, which is A bottom. All right, so let's start plugging numbers in now. So this is 2 times. The area of a single base is 24 square centimeters, plus the area of the top is 40 centimeters squared, plus the area of the left rectangle is 24 centimeters squared, plus the area of the bottom is 32 centimeters squared. Okay, let's clean this up a little bit. So the order of operations tells me I have to do this multiplication first. So this would be 2 times 24 is 48 square centimeters, plus 40 square centimeters, plus 24 square centimeters, plus 32 square centimeters. And if you put the area of all these faces together, we plug this into our calculator. 48 plus 40 plus 24 plus 32 give me 144 square centimeters. And that is the area of that right triangular prism. Okay, let's look at a different one. This one's going to be a little bit more complicated to look at. Okay, so once again, I'm going to start off by doing the bases. So the base is going to be this one. The bases are the triangles, and this one right here. Okay, so these little hash marks, they mean that the length of both those sides is the same. So if this side is 22.9 centimeters, then this side right here is also 22.9 centimeters. So let's start off with the bases. Okay, so the length of this base is 22.5 centimeters. Now, you seem to have a bit of an issue here because you might be wondering, well, what do I use for the height? Do you use this 20 centimeters or do you use this side length, the 22.9 centimeters? When we're calculating the area of a triangle, when I said is length times width, it's length times the width that is perpendicular to the length. So what I want is I want this one. This is going to be the height that I want to use because it is perpendicular to the length. I do not want to use the 22.9 centimeter number to determine the area of the triangle. We can call that like the slant height, but I do not want the slant height. I want the perpendicular height. Okay, so I'll just draw this perpendicular height. Okay, draw a little square to show that it's perpendicular. And let's just label that height. So from bottom to top, we can see on the picture here. Let's see, I should erase this to make it a bit cleaner. Okay, that perpendicular height is 20 centimeters. Again, you must use the perpendicular height for getting the area of a triangle. Do not use this one. Okay, we'll use that for the area of the rectangle, but you do not use that slant height in the area of the triangle. Okay, so this would be 20 centimeters. Okay, so let's calculate this now. So the area of, so I'll say a base is equal to length times width divided by 2. So it's going to be 22.5 centimeters multiplied by 20 centimeters. And we're going to cut this in half. So area of the base, one of the bases is going to be, well, 20 divided by 2 is 10, and then 10 times 2, 22.5 should be 225 square centimeters. And this repeats twice. So I'll write down multiplication by 2. Okay, so you got 2 of these bases. Okay, let's clean this up. Now, let's look at the right face. So the right side face is going to be this one. Okay, and we'll view it from this perspective, looking at it from the right. So I'll say right face. Okay, so I'll sketch my rectangle. Okay, the length of this rectangle is actually this length here. So this length is the full length of what that rectangle would be. So we can label that as 50 centimeters. And the width of the rectangle is actually going to be this slant height now. Okay, so this slant height represents what the slant height of the triangle represents the width of the rectangle on the side. So that's going to be 22.9. So even though we don't use that slant height for the area of a triangle, we do need to use it for the area of the rectangle. Okay, so then area of the right face, let's just abbreviate right with R. We'll say AR is equal to 50 centimeters multiplied by 22.9 centimeters. And the area of the right face would be equal to, let's plug this in. So 50 times 22.9 would give me 1,145 square centimeters. Let's erase this again. And now let's go to the left face. So the left face is going to be on this side. Okay, and we're going to look at it from this perspective. Actually, we don't need to draw the left face because the left face and the right face, they actually both have the exact same area. Because if you look at this left face, it would have the same length, which is 50 centimeters, and the width of the rectangle is actually just this slant height, because we identified here that this side length and this side length are the same with those hash marks. So actually that number is also 22.9 centimeters. So we do not need to draw another face because they're the same thing. So actually we're going to write down here, let's just change this. So we'll say right/left face. And then we can change this to ARL, and then we multiply that by 2 because we have 2 of these. So now all we have to worry about is the bottom face. Okay, so the bottom face is going to be this one. Okay, and that's going to be it's going to be similar to the left-right face, except it's a little bit smaller just because this side length is smaller than 22.9. So it would be a rectangle with the same length, but just its width is going to be a little bit shorter. Okay, so this width would be 22.5 centimeters. This is the perspective if I looked at it from underneath. And then the length of it is going to be also this length right here. The bottom one's going to have a length of 50 centimeters. And this face only occurs one time. So now I have my 5 faces, the 2 bases, the right and the left face, which are the same dimensions, and also the bottom face. So we'll do AB for the bottom. Just note here, if you did AB for the bases and AB for the bottom, you need some way to distinguish them. So that's why I wrote down A base for that one. Okay, so A for the bottom would be length times the width, which is 50 centimeters times 22.5 centimeters, because we're dealing with a rectangle. And we have A base would be equal to 50 multiplied by 22.5 is 1,125 square centimeters. To figure out the total surface area, so the total surface area would be 2 times the area of one of the bases plus 2 times the area of one of the left or right side faces, so 2RL, plus just 1 times the bottom face. Therefore, we can just write down plus AB for the bottom. Let's plug the numbers in. So we'd have 2 times the area of the base, which is 225 centimeters squared, plus 2 times the area of one of the right or left faces, so 1145 centimeters squared, plus the area of the bottom face, which is 1125 square centimeters. Okay, and then now let's just order of operations, do the multiplication first. So 2 times 225 would be 450. 2 times 1145 would be 2,290 plus the area of the bottom, 1125 square centimeters. Okay, add these numbers together, and then we get the total surface area. So that is going to be 450 plus 2290 plus 1125 is going to be 3,865 centimeters squared. Just note here that the procedure compared to like how I found the surface area of a right rectangular prism is the exact same. So you start off by drawing each distinct face, you label the dimensions, you identify how many times each face repeats, you figure out the area of all those faces, and then you just add them together to get the surface area. The major difference here is that when you're dealing with a triangular face, the equation for calculating the area of a triangle is a little bit different. It's just half the area of what a rectangle would be. Okay, so you can complete in the surface area and volume work booklet the assignment called surface area of right triangular prisms. And then in the next lesson, we'll talk about calculating the surface area of a right cylinder. And I'll talk to you